All right, we're going to introduce a word that you've probably heard before, but we're going to hear a lot of this word, so you need to know what we're going to talk about. So the very beginning of this is very, very simple, basic definition kind of stuff, and eventually we're actually going to do some math. But the beginning of it is just knowing some words. So let's take good notes, write down the words, and you will see these. I was going to say from time to time. You're going to see this a lot. You're going to see that word polynomial a lot. First of all, before we talk about a polynomial, anybody know what that prefix means, poly? Nobody? Like if I say polygon, a poly anything, it means something. It means, it's not just a math term. It could mean all kinds of things. Nobody knows? It means many, multiple, good. Okay, or many. Oops, that's a weird many. All right, so that means many. And what's the nomial thing? Well, that's what we're going to talk about right now. Okay, they're just terms. So the word nomial, I don't know if it's like got an exact definition, means terms, but the word polynomial means many terms. So let's talk about what a term is. All right, so monomial is mono. What does the prefix mono mean? If poly means many, mono means what? One, right. So this just means one term. Okay, now they write it in a fancy way. I was debating whether even to write this down, but I'm going to. All right, so I've got this is a monomial. What in the world is going on here with that nonsense? Well, this A right there has a special word. We call that a coefficient. You might have heard that word before. This right here, it's an exponent, but we're going to look at it a little differently today. I'll put it in parentheses. We're going to call it the degree of this monomial. We'll talk about that in a minute, but that means it's the degree. And this x right there is just a variable. All right, so let's give some examples. In fact, example 1 is just giving a bunch of examples of what a monomial is. All right, so here's the monomial, 6x squared. What they're going to do is they may ask you, I don't even know, I don't have the problems in front of me, but they may give you some questions where they say, what is the coefficient of this monomial? All right, so we're going to list all the coefficients. We're going to do about 5 of these, and then they're going to ask for the degree. Let's talk about the degree first before we do this. So where do you find the degree? You find the degree right there for the exponent, okay? So we just got a list. I'm going to list a whole bunch of these in a minute, okay? Well, like 5 of them. But let's just list the coefficients. So here's your monomial. It's one term. Which one of these 3 things is the coefficient? It's the 6, right? So we just write down 6 for the coefficient. Which one would the degree be, or the exponent be? It would be the 2, that's right. As simple as that, super easy. I said it was going to be easy to start with. Eventually, again, we're going to do some math, we're going to do some stuff that's a little bit more involved, but right now we're just trying to get our words down. Here's another monomial. I mean, there's an unlimited amount of monomials, but these are certain types of monomials. So again, let's look at this. Which one of these numbers would be the coefficient? Yeah, that's it. Negative square root of 2. That would be your coefficient. The coefficient is just the number that's being multiplied by your variable, okay? So it's the number out in front is what it means. And what's your degree here? It's 3. Yeah, very simple. Again, not trick questions. Whoops. Not trick questions, just really, really easy. Now, this is a little bit tricky. What if you just put a 3? What if I just said 3? Does this really fit that pattern of having a coefficient, a variable, and an exponent? It doesn't look like it, does it? But it does fit it. I'll show you. What do you think the coefficient would be? The 3. What about the variable? Where's the variable? I don't have one, and I don't have an exponent. Well, you could probably say 3 to the first, but that's not the exponent to the variable. Watch this. This is where it's a little bit tricky. We could write it like this, 3x to the 0. Why could I write it like that? What is anything to the 0 power? Did we talk about that earlier this year? Is it? Oh, yes. I'm sorry, I was thinking of something else. It is a 1. It's not x to the first, it's just a what? A 1. So what's 3 times 1? It's 3. So you could write 3 like this, couldn't you? The only reason we're writing it like this is so I can see which one's the coefficient and which one's the degree. All right? So the coefficient, like you said, would be 3. What's the variable? The variable is x. So what's the degree? What's the exponent? It's 0. So the degree of that would be 0. So that one is a little bit trickier. Here's another one that's a little bit trickier, but it's along the same line of what we just did. All right? Negative 5x. So everything's there except for one thing. What's the one thing that you don't really actually see? The degree, right. So what would the degree be? It would just be a 1, right. X is just the same as x to the first. Now it's easy to see. What's the coefficient? Negative 5. What's the degree? It's 1. Good. And one more. What if you just had x to the 4th? Now again, it's got 2 of the 3 things. What is it missing? The coefficient. What would the coefficient be if there's no number out in front of it? It's just a 1. It just means you have one of those things. Okay? Everybody with me? So, what's the coefficient? It's 1. What's the degree? 4. Easy. Yeah? Yeah, good. All right, let me give you a couple examples of things that would not be a monomial. And there's one thing that I didn't, I'll just wait till I get to it. There's one thing that I kind of left out about the degree that I'll talk about when we do this. So this is example 2, but it's actually a non-example. Okay, so this is a non-monomial, or it's just not a monomial. I got 3x to the 1/2. Now this looks like 3 would be the coefficient, and it's true, 3 would be the coefficient. But look at the degree. The degree is a 1/2, and you'd think you'd put 1/2 for the degree, right, up to what we've been doing. But they give a more specific definition of degree. They say that the degree has to be, first of all, it has to be an integer. Actually, I should say this. I won't even put the 1 there. The degree has to be a positive integer. So it is positive, so we're good so far. But is that an integer? Is 1/2 an integer? What are the integers? We talked about this, had it on the test, didn't we? Yeah, it's like positive or negative whole numbers, including 0. 0 is a whole number. So positive integers would be what? Well, 0 is not positive, so what's the first positive integer? 1, and then 2, 3, ... Okay? Well, a whole number is 0. Right? And so, well, actually, you could have it. Yeah, you could. You could have said whole numbers, but the book says, the book actually makes it even more complicated than that. They say it's x has to be greater than or equal to 0, or an integer that's greater than or equal to 0. All right? But yeah, you could just say they got to be whole numbers. Right? That's perfectly fine. Is that a whole number? It's not. So it doesn't have a degree. So what's the degree? It's got none. All right? That's what you would say. Now there's a difference between having 0 and having none. All right? You can have a 0 degree like we did with that 3 earlier. Okay? But this is none. Here, I'll give you another one. What if you had 4x to the negative 3rd? You know the coefficient is 4, but what's the degree of this thing? It's none. Why is it none? It looks like it's right here. It looks like it should be negative 3. But the degree has to be what? A positive integer. That's not positive integer. It's an integer, right? Negative 3 is an integer, but it's not positive. So again, you would say none for the degree. All right? Not difficult, not hard to understand. It's just, if you didn't know the definition, you just wouldn't know how to do that. All right, let's talk a little bit more about monomials, and we'll get to some more terms instead of just one term. So what if you had this? What if you had 2x to the fourth and negative 5x to the fourth? Are they both monomials? Yeah, they got a number out in front, they got the variable, they got the coefficient, they got the variable, and they got this as a positive or a whole number exponent, right? Same thing here. Can that be negative? Yeah, it's just the exponent can't be negative. Okay? Everybody with me so far? All right, so, but there's something in common with these. What does it look like is in common with both of these? They both have x to the fourth, don't they? All right? So the variable and the exponent are exactly the same. Now the coefficients are different, okay? But the variable and the exponent are exactly the same. What do you think we call these things? Because we could add them up or we could subtract them. So we call them what? Like terms, right? These are called like terms. I'm sure you've heard that before in your algebra. Have you? Yeah, they're like terms. But you're like, Mr. Hamrick, that's got a 2, that's got a negative 5. They're not exactly the same. Well, that's true. What is the 2? What does the coefficient really mean? It means you have 2 of these things, right? And this means what? You have negative 5 of these things, right? But these things are exactly the same, aren't they? All right, so they're like terms. Make sense? Let's do another one. What if you had 3xy and negative 2xy? Yeah, you still got like terms. What is your actual term? It's the xy, isn't it? Okay, the coefficients could be different, but the term itself have got to be the same. This has an xy, that has an xy. They're exactly the same. This doesn't have an x squared, right? This doesn't have a y cubed. It's just 1x, 1y, 1x, 1y. They're like terms. So if these are like terms, you could add or subtract these like terms. So let's do a couple examples. Let's just do this number right here. Might as well. What if I had 2x to the fourth minus 5x to the fourth? All right, and I wanted to figure out what the answer is here. What would I do? Well, first of all, they have the same like terms. It's like this. It's adding. You ever hear anybody say you can't add apples and oranges? You heard that phrase? All right, you can add apples together, right? If I have 2 apples and 3 apples, I got what? 5 apples. Okay, if I got 1 apple and 1 orange and 2 oranges, I got what? 3 oranges, okay? But if I say, I know what you're going to say on this but if I had 3 apples and 2 oranges, right? I do have 5, people would say, like, you got 5 pieces of fruit. Okay, that's true. But do you have 5 of either one? No, all right? So you can't really add those together. So it's like this. I got 2 of these minus 5 of these. So all I do is just add up the coefficients. So what's 2 minus 5? Negative 3. Negative 3 what? Oops, come on. No. How many? I got 2x to the 4s. I got minus 5x to the 4s. And now I got what? Negative 3x what? To the 4th. Notice, I don't add those exponents. This is where it can get confusing. All right? Because what if I had this? What if I had 2x to the 4th times negative 5x to the 4th? Then you would add the exponents. So if this was multiplication, what would we do? 2 times negative 5 is negative 10. X to the 4th times x to the 4th, when you multiply with the same base, what do you do with the exponents? Add them up. So that would be that. You see the difference? But this is subtraction or addition, okay? So 2 of these minus 5 of these. 2 minus 5 is negative 3 of what? What's my term? It's just x to the 4th. I got negative 3 of these things now. Does that make sense? A lot of people will get confused between this and this. Don't be one of them. All right? Yeah, that's good enough for that. Let's go to the next thing. Let's talk about a binomial. All right, so if monomial meant one term, what do you think a binomial means? Two terms. By the way, let's go back to this. What if a lot of people might think that this is a binomial because there's two different terms, right? That's one monomial, that's another monomial. How many do I have? I got two of them, right? But the thing is, I can add those together, and what does this combine to be? Just one. And so really, if I combine them, simplify it, that's a monomial. Would you agree? So a binomial are two terms that don't combine into one, all right? Does that make sense? If I add them together, they don't combine into one. So let me give you a couple examples of a binomial. So for instance, here's an example. Let's say, I'll just stick with the book. Right there. Can I simplify those and make them one? No, because that's an x squared, that's a 2, they're not like terms. There's nothing I can do with that. All right, so I just leave it like that. So that would be considered a what? A binomial, because there's two terms. Here's one term, here's a second term. Make sense? Yeah. For some of you guys, this is going to be like way too easy, but we got to make sure everybody's on the same page here. What if I had this? What about that? Can that simplify to be a monomial, or is it a binomial? They both have x and y in it, and they both have squareds in it. But what? What do you see? This x is squared. Is this one? It's not. So just that alone makes these not like terms. So these are not like terms. I cannot subtract them from each other. There's nothing I can do with it. But it is called a what? A binomial. All right? And of course, you got a monomial 1, binomial 2. What do you think the next one is? A trinomial. And that's all the ones we give words for, okay? After that, if I had 4, 5, 6, 7 terms, what do you think I would call that? A polynomial, that's right, okay? So I don't give a specific name any further than 3, all right? So we'll stop at 3. So let me just give you an example of a trinomial. Thank you. All right, so let's do this. Okay, there's 3 terms. You see them? There's one term, there's a second term, there's a third term. Are any of those terms the same? Any like terms here? I mean, that has an x and a 3, but that 3 is not really a 3, is it? It's a cubed. And this 3 is being multiplied. So even though they have an x and a 3, they're not the same term. All right, they're 3 completely separate terms, so we can call that a trinomial. Enough of that. Everybody got that down? Now, I'm going to give some examples of polynomials, and we're going to do that whole coefficient and degree thing again, all right? But this time it's not going to be a monomial, it's going to be a polynomial. It's going to be several. Some might be binomial, some might be tri, but some might be more. So what is this thing? All right. So there's our polynomial. And again, I'm going to find the coefficients. All right. And then I want to find the degree. Now, when we did the degree before, we only had one monomial. All right. On this one, I got more. I got 1, 2, 3, 4 of them. So in order to find the degree, you find the one that has the largest exponent. Everybody hear me on that? Because look, I got an x squared or x cubed, I got an x squared. I technically have x to the first there. And even more technically, I got x to the 0 there, don't I? So which one of those is the degree? It's always the highest one. All right, so what's the degree of this polynomial right there? It's a 3, right, because you look for the biggest exponent, and that's what your degree is. It's pretty easy, isn't it? By the way, what are your coefficients? Now, you got 4 of them, though, don't you? Right, instead of just 1. So what are they? -8, +4, -6, and +2. All right, so those are your coefficients. Let's do another one. What if I had this? 3x squared minus 5. Here's another thing. Notice how they wrote this polynomial. They went 3, they went x to the third, x to the second, x to the first, and technically this was x to the 0, wasn't it? Do you see how they went in order from the largest degree down to the smallest? That's called descending order. All right, that's called descending order. It means it goes from the highest degree down to the lowest degree. And it fits everything in between, right? There's 3, 2, 1, 0. What about this one? I got 3x squared. I need to fill in all the other x's. If I start off with x squared, what's the x term? I don't have an x term in here, do I? So how could I write that if I want to find the coefficients? How would I write an x term in there with it not really being there? I could add a what? No, not a 1, because if I put a 1, okay, it's a 0, that's true, but it's going to be what? 0x. Remember, I want to go in order. This goes 3, 2, 1, 0. This just starts at 2 and it goes down to 0, right? Right? 5x to the 0, would you agree? What am I missing? I'm missing an x, aren't I? So what am I going to write? 0x to the first plus, I'm sorry, it's not plus, it's minus 5x. Or just 5. Yeah, you can put x to the 0. All right? I know that might be a little confusing, but this is what we got. Now look, do I have it in descending order? Yeah, I got 2. I start off at 2. What's the next one have to be? A 1. What's the next one have to be? 0. So I wrote that like this. Now I didn't simplify it. That's way more complicated than what this is. But what are we trying to do though? The whole reason of me doing this is to find the coefficients. So what are the coefficients? Well, I got a 3. What's my next coefficient? No. It's 0, right? All right, that's my next coefficient. You see that? Because I'm looking at this whole thing right here. So what's my next coefficient? It would be a 0. And then what's my coefficient of this one? It's -5. All right? It goes in order from x squared to x to the first to x to the 0. What's that? Oh, the degree, I'm sorry. Yep, I forgot about that. The degree is 2. That's the highest exponent, so the degree would be 2. Let's do another one. What if I did this? 8 minus 2x plus x squared. So what I want to do is I want to rewrite it so I see it in descending order. Is this in descending order? Is it from the highest power down to the lowest? It's not. So let's put it in descending order. So what would go first? X squared. Yeah, don't say x2. X squared. What would be next? No. It's not a 2x. What is it? It's a minus 2x. Good. And then what? Plus 8. Okay? All right, everybody see that? So what did I just do? I put it in what? Descending order from the highest to the lowest. All right? What's your exponent to this one? That's 1. What is it here? That would be the same as x to the 0, wouldn't it? Okay? So let's go through and write down the coefficients. What's the coefficient to this first one? There wasn't one there, so it's always a what? It's a 1. What's my next one? -2. What's my next one? An 8. So those are my coefficients. What's my degree? It's 2, because you look to see which one is the highest one, and that's 2. So, boom, there you go. All right, let's do another one. 5x plus the square root of 2. All right, this isn't that hard. This is easier than the other ones. What are your coefficients here? Well, this is x to the first, isn't it? And this is just a number, so I could always put x to the 0, right, if you want to put it like that. So what's your coefficients? 5. And what else? Square root of 2. Good. All right, that's your coefficient. That's your coefficient. What's the degree of this? I got a 1 and I got a 0, so what's the degree? It's just 1. Really easy. One more of these. We did this already. What if you had 3? Just the number 3. Is that considered a polynomial? Just a regular number? It kind of is. All right, because look, there's a 1 being multiplied by it, right? Actually, I shouldn't say that. There's a 3. Isn't that the same as 3x to the 0? Yeah? Okay. So, remember, we just started off with 3. Why did I write it like that? Because I wanted to put x's with everything, all right? That's all. So what's your coefficient here? It's 3. What's the degree? Is it? What did we say has to be true about the degree? Wait a minute, hold on just a second. Now this goes against something that I said earlier, so I got to double check. Yeah, see, that's weird because it says that the degree has to be greater than or equal to 0, and that is a 0. So the book says there's no degree on this one. I'm gonna have to look at that a little bit later because it looks like it would be 0, doesn't it? Because the degree has to be greater than or equal. Yeah, I have to look at that. I have to look at the explanation. I don't know. Anyway, that's what they say in the book. I would agree with you, what you guys said. Again, according to how I taught it today, it should be a 0, but I must have said something wrong at the beginning. I'll go back and look, and then maybe tomorrow we'll let you know. All right. Maybe. Yeah, I'll have to double check it. All right. It's really not that big of a deal. We're not going to really use that all that often, so it's not that big of a deal. All right, we got 5 minutes. I can do this next part in 30 seconds. All right, so we're going to do a non-polynomial. We did a non-monomial, right? What was a non-polynomial? Now watch. What if I had something like this? 1 over x. This is a non-polynomial because really it can be written as x to the negative first. So what's the degree of this? This is not greater than or equal to 0, is it? So technically, it's not a polynomial, all right? So anything as a fraction is not considered to be a polynomial, all right? What if you had this, last one? Same thing with this. This is a non-polynomial, so these are not polynomials, all right? I thought we'd be able to get to this next part today, but we're not going to. But I will do a little sneak preview. So we're going to learn how to add, subtract, and multiply polynomials. We'll do that tomorrow. It's supposed to be today, but that's all right. Okay, so that's what we're going to do tomorrow, add and subtract. We kind of did a little bit of that today when we talked about adding like terms. We're going to do quite a bit more with that, and then we're going to do quite a bit with multiplying. Okay, multiplying is where it gets a little bit more complicated, I guess, but we actually did one of those today as well, didn't we? Did we multiply? Where did we do that? Yeah, right there. Look, so that was actually multiplying polynomials, and this right here was actually adding or subtracting polynomials. But we're going to get way more involved. They're going to be a lot longer. You're going to have a lot more like terms and that kind of stuff, all right? So if you looked at the lesson plans on facts or yesterday, did I put them up on the screen yesterday? Maybe I didn't because you guys took the corrections. But anyway, it is up on Facts if you want to look, or RenWeb. It does have an assignment. If you want to do some of those, you could probably, oh, I got it right in front of me. So I'll tell you what the assignment is. I'm not going to have you do them all. And again, I don't have the book right in front of me, or the problems right in front of me, so I can't tell you which ones to do. But I'm going to, tomorrow, assign 27 to 45, just the odds. So towards the beginning, if you see any problems like these where it says find the coefficient, find the degree, all that kind of stuff, do those. All right, I'm not sure where it starts actually doing the addition and subtraction. It may even be before 27, I don't know. But look at it, try to get as much done as you can, because that way tomorrow you'll have a little less to do. All right, so I think that's a good idea. Everybody good? Okay.